This question says, find the slope of the line containing the pair of points, -7, 5, and 3, 3. So we have a formula for slope, and the formula for slope involves having 2 points on the line, and the formula is y2 minus y1 over x2 minus x1. And that's when your ordered pairs or points on the line are x1, y1, and x2, y2. So we'll label these points that we're given as x1, y1, and x2, y2, and use the formula to calculate the slope. So for our slope, we have y2 being 3, minus y1 being 5, over x2, which is 3, minus x1, which is -7. So that would give me a -2 in the numerator, and in the denominator I have minus a negative, which is plus. 3 plus 7 is 10, and I'll reduce that fraction to be -1/5. So the slope of the line containing the points -7, 5, and 3, 3 is -1/5. This question says, find the equation of the line passing through the points -5, 6, 3, 6. Write the equation in point slope form, slope-intercept form, and standard form. So let's write down what these different formats are first. So for point slope form, that would be y minus y1 equals m times x minus x1. For slope-intercept form, that would be y equals mx plus b. And for standard form, that's ax plus by equals c. These are all ways of writing linear equations. And to find the equation in this problem, we're going to use the point slope form. And with the point slope form, we need the slope, which is m, and we need a point on the line x1, y1. And once we have those two things, we'll be able to build the equation with the point slope form. In this example, we were given 2 points on the line. So before we can use the point slope form, we have to calculate the slope. So let's calculate the slope with the slope formula, which is y2 minus y1 over x2 minus x1. We'll label one point as x1, y1, label the other point as x2, y2, and then calculate the slope. So that's going to be y2, which is 6, minus y1, which is 6, over x2, which is 3, minus x1, which is -5. 6 minus 6 is 0. In the denominator, we have 3 plus 5, and that's 8. 0 over 8 is 0. So we have a slope of 0. Now that we have the slope, we'll be able to write the equation of the line using point slope form. So using a slope of 0 and one of the points, it doesn't matter which one, so I'm going to choose the one that just has positive values. We'll substitute those into our point slope form. Y minus y1 equals m times x minus x1. We have y minus 6 equals 0 times x minus 3. And 0 times anything is 0, so we have y minus 6 equals 0 for our point slope form. So this is our point slope form. And then we want to convert that to our slope-intercept form. And with our slope-intercept form, as we saw above. Slope-intercept form has y by itself. So to convert to slope-intercept form, this to slope-intercept form, we're going to start with that y minus 6 equals 0 and get y by itself. That's y equals 6. That's our slope-intercept form. And then finally, we want to write it in our standard form. Our standard form is here, ax plus by equals c. And with our standard form, we have both x and y on the same side. And we already have that in this example. So this is also our standard form. There is no x in this equation. So we found the equation of the line in point slope form to be y minus 6 equals 0, slope-intercept form to be y equals 6, and standard form to be y equals 6. This question says, determine if the relation is also a function. Give the domain and range of the relation or function. So in order to determine if the relation is also a function, we need to remember the definition of a function. So for a definition of a function, every x has exactly one y. So as I'm looking through this relation, what I want to focus on the x's. I want to make sure that those x's have exactly one y. To do that, I'm going to look for the x's to see if they repeat. So I have an x of 9, I have a different x of 5, a different x of 8, a different x of 1, a different x of 3, and a different x of 4. So those x's never repeated, so we don't have one x relating to more than one y. We can also build a chart for the domain and range and show the relationship. So we can write down the elements in the domain to be 9, 5, 8, 1, 3, 4. If the element in the domain ever repeated, you would only write it once. For the range, we have values of -2, 0, 6, 4, 6. So since that 6 repeated, we're not writing it again. And then 2. And then we would draw connections between these values for every ordered pair that we have. So we have an ordered pair of 9, -2, so that corresponds. 5, 0, 8, 6, 1, 4, 3, 6, and 4, 2. So if you're trying to determine if you have a function, you're going to focus only on the domain values, not the range values. And what you're looking for is how many connections each x has. Every x should have exactly one connection or one y value. So this 9 has one connection, 5 has one connection, 8, 1, 3, and 4 all have one connection, so we would say that this relation is a function. And then we want to state the domain and range. So we're going to use our curly braces to list the items in the domain. That's 9, 5, 8, 1, 3, 4. We separate those items by commas. And for the range, we'll also use the curly braces, -2, 0, 6, 4. Remember, we don't write the 6 a second time. We just write it one time when you write it in the set. And we have our range. This question says, sketch the graph of y equals 1/2 x cubed by plotting points. These are the points that we're going to plot. We're going to fill in this chart for these x values, and we'll graph it on this grid here. So we have the equation y equals 1/2 x squared. And we're given that we have an x value of -2, and we want to find the ordered pair that goes with that x. So we're going to substitute, excuse me, I noticed that I wrote a squared here instead of a cube. So we're going to substitute in for x, -2, and then work out what the y value is. -2 cubed is -8. And half of -8 is -4. So right here we would write -2, -4 as the ordered pair. And we'll repeat this process over again with an x of 0. So with an x of 0, if we substitute that in, we would have 1/2 times 0 cubed. 0 cubed is 0, and half of 0 is 0. So in this blank, we would have the ordered pair 0, 0. And we'll repeat that again with an x of 1. We would have y equals 1/2 times 1 cubed. Following order of operations, we're going to do the exponent first. 1 cubed is 1, and half of 1 is 1/2. So in this spot here, we would write the ordered pair 1, 1/2. And then finally, we'll repeat that again with an x value of 2. We have y equals 1/2 times 2 cubed. That's 1/2 times 8, which is 4. So in this spot here, we would fill in the ordered pair 2, 4. So now we've found our ordered pairs, and we're going to draw a sketch of the graph. So we're going to plot these ordered pairs that we just found, -2 and -4. And then we have 0 and 0, 1 and 1/2, and 2, 4. And we're going to sketch out this graph of a cubic. Looks like this. I didn't do a great job of drawing that, but it's a sketch. So we have the graph of y equals 1/2 x cubed.